Good afternoon, everyone, and thank you for being here for our workshop dealing with smarter compliance for next-gen nuclear design, where we show you how artificial intelligence can support system engineering to accelerate and support nuclear design. So my name is Béranger Fister, and I'm a digital transformation engineer at the Fuel Cycle Dismantling and Defense Business Unit for Assystem, where I'm in charge of leading innovative projects and deploying digital tools to enhance the efficiency of our business unit teams. And I am with Xavier Busneau from Dassault Systèmes, who spent 20 years working on business transformation for the main energy and nuclear actors as a business consultant director.
Yeah, so at Dassault Systèmes and Assystem, we have a shared ambition. This ambition is to accelerate the deployment of nuclear energy. And we do believe that the nuclear industry has to continue the business transformation it has engaged so far by adopting new engineering methods and delivery best practices, but also by deploying model-based approach for know-how and IP management and embracing AI as a way to bring digital performance and productivity. And we do believe that this is needed in order to reach the objective of accelerating nuclear energy development and delivery at scale with our customers. What we are going to demonstrate today is more than an experiment. In fact, it's the result of a long-term partnership that we have engaged with Assystem. And so what you will see is really this outcome and the tangible proof of the results of this partnership.
So let's start with a presentation of the context of our solutions, which lies in today's nuclear challenges, especially with the new infrastructures to come, such as the EPR2, the emergence of AMRs and SMRs, and the advanced fuel cycle to come. All of these new infrastructure are bringing new technical concepts that brings an evolving system complexity and an evolving regulatory frameworks. All of that generating new engineering data to manage. On the other end, we already know that nuclear projects involve a huge amount of documentation to deal with and involve many teams from diverse disciplines to work together to ensure that the facility can operate properly. Another challenge is the long design cycle in nuclear projects where data has to be managed for years and decades. And at the same time, nuclear operators are facing pressure to reduce the time and the cost of their projects, forcing them to accelerate the nuclear design. So as a result, there is an increasing number of requirements to deal with, which take a large amount of time and leads to human error, which is not acceptable in a nuclear context. So let's illustrate that with how we apply the compliance in today's nuclear projects. So everything starts with the needs and the requirements that come from the documentation, such as a specification report, but also laws and standards. And these requirements are passed on to design teams, and they guide all the design phase, which is to the final facilities design, which is done through models, but also documentation. And the final steps consist in verifying and validating that all the technical choices are fully, that all the initial requirements, are fully met by the technical choices, and this is what you call the compliance. And all of these steps, and especially the compliance, is done by a technical coordinator that do it manually, and it takes hours for him to gather information, cross-checking documents, and ensuring the traceability through documentation. So this manual and non-optimized process implies a long verification cycle and a high risk error.
So we are going to show you how to address this compliance challenge by combining the strengths of Dassault Systèmes Virtual Twin approach, 3D Experience Virtual Twin approach, and Assystem DeepRec solution. The 3D Experience platform is a collaborative innovation platform that at the heart of this platform is the Virtual Twin approach, which combines model-based system engineering, parametric and generative design with data science framework, an AI-ready data science framework, And these data science frameworks help our customer leverage their unstructured and structured data in order to solve business challenges through, let's say, data perspective or dynamic generative experiences. And so now, Béranger?
Yes. So the generative system engineering project aims to bring system engineering tasks automation thanks to our tools DeepRex, which is an AI tools. And in today's example, we'll show you how we automated the generation of the compliance matrix and the associated compliance report. And what we are going to show you today is a use case of a ready-to-use solution which aims to save valuable time for the technical coordinator while ensuring the integrity of the design.
So as Béranger mentioned, the use case we target today is how to solve a compliance challenge, starting from a virtual twin of a design, let's say a small modular reactor design, which has been done within the 3Experience platform. Then how to leverage the design artifact and feed an AI with this design artifact in order to assess the compliance of a design to the requirements. Then we will show how you can easily review the compliance analysis provided by the AI in context of the virtual twin of the small modular reactors, connecting AI-generated results with the models and the artifact of the design. And at the end, we will also demonstrate how to automate a compliance report, again, leveraging model-based information and AI. Yeah. So for this demonstration, we developed a virtual twin of a high-temperature gas reactor, so focusing on the reactor cavity cooling system. So the reactor cavity cooling system, I don't want to do too much into the technical details, but the idea is this reactor cavity cooling system extracts the heat from the reactor cavity through cooling standpipes and evacuate the heat. It has both an active mode in normal operation and a passive mode when you lose the external power source. So to design this concept of high-temperature gas reactor, we followed a standard V-cycle, starting with the needs and stakeholder requirements, regulatory requirements. Then we applied a model-based system engineering approach to define the right architecture. And we went into the detailed design in 2D, in 3D, and then up the V-cycle through simulation, integration, and validation. And once we have done this virtual twin of our small modular reactor, it's where we are able to apply and go for compliance review. So let's discover together this virtual twin. So we start, 3Experience comes with the system engineering method and an authoring tool, which is called Katia Magic, where system architect can analyze the requirements, refine these requirements into operational use cases, and then detail the system subsystem, specify the functions, the interfaces, and even allocate requirements or track the allocation of requirements to system functions and interfaces. Once the architecture has been set up and defined in model-based system, all the requirement specification, the system specifications are available in the 3Experience for system engineers to do their detailed design and to connect their design to the N3D to the requirements, ensuring traceability and digital continuity. So when we spoke about digital continuity, the benefit of digital continuity is to enhance the productivity of the engineers, whereas traceability brings the value of being able to do quick design review and performance design review, to also do impact analysis or coverage analysis based on your design. So this is what we show here, how we are able to connect from requirements to all components and design elements. Vas-y, tu peux.
So now that Xavier showed you how we implement all this data in 3D experience, I'll show you how we automated the compliance generation. And let's start with the presentation of our tool DeepRext, which covers a range of use cases related to requirements, from the extraction and classification to the compliance analysis. So it's based on a microservices architecture where all applications are connected with each other, and every single application can be used independently regardless of specific need. So it is built to handle operational constraints such as data sensitivity, but also the possibility to work with traditional engineering platforms such as 3D Experience, but also as a standalone solution. And finally, technically speaking, it relies on specific developments such as document collection, dataset creation, and specific AI techniques enable him to work with a nuclear technical framework. So today's use case is straightforward. The technical coordinator imports the requirements from the RBS, initially stored in 3D Experience, into DeepRext, and the design report that contain the technical specification of our HTGR, and then DeepRext analyzes for each requirement whether the design report correctly addresses it through the technical description or not. And it gathers all this justification in a compliance matrix that can be exported from DeepRext and re-imported into 3D Experience. So to dive deeper in the functioning of DeepRext, it involves two main processes. The first one is the document processing. So we run the design report through a parser that extracts text, sections, tables, and it detects the main languages of every information, and all this information are gathered into a file which is then stored in a database, and it's finally cut into multiple paragraphs, and each paragraphs get a unique ID so the AI can identify it easily later. And once the document is ready, we can launch the compliance generation by uploading the RBS. And so DeepRext analyzes for each requirement. Thanks to smart search techniques, it compares the requirement with all the previously analyzed paragraphs, and it selects some paragraphs of interest. And then it produces, thanks to an LLM, technical justification regarding the requirements and the selected paragraphs to then gather all this information in the compliance matrix. And this is what I'm going to show you now. So we are in the DeepRext environment. So the first thing to do is to process the design reports that we can have an overview here. So it extracts every data and creates the paragraphs. And once it's ready, we can launch the compliance generation by selecting the requirements that we want to check and the documents that we want to compare them against. And the AI hence generate a justification and a compliance state through three possible states, which are compliant, partially compliant, or non-compliant. And we finally reach the compliance view. And here we can have the compliance status of all the requirements. And let's take an example of a non-compliant requirement, which asks the RCCS to have 8 branches of heat removal. And the AI explains its justification that there is no specific mention about these 8 branches. That's why it's not compliant. And below, we can see some paragraph of interest that we can open directly into the document to get more information and details. And let's take an example of another partially compliant requirement. And this one asks the RCCS INC system to be cyber secure. And the AI explains that the global INC system of the HTGR is cyber secure, but there is no specific mention for the RCCS one. That's what it's partially compliant. So once again, we can have the paragraph of interest. So the technical coordinator can open it and read that the INC system is effectively based on cybersecurity protocol. And so it's now up to him to decide whether it's enough or not for the compliance of this requirement. And finally, we can export all of this compliance data and import them into 3D experience to apply the compliance review that Xavier is going to show you. But just before, I wanted to share with you some results about the AI. So in terms of time saving, it took 14 hours to the technical coordinator to apply this verification, including the reading of the report, the searching for information, and the writing of justification, where it took him only 2 hours to do that thanks to AI, including the processing and the verification, which is needed. And in terms of quality of the result, the AI gave 65 good justification out of 76 requirements. For 8 of them, it missed some relevant information in the paragraphs, and for 3 of them, it just couldn't conclude properly. So now Xavier is going to show you how we can apply the compliance review with this data into a 3D experience.
Yes, so as Béranger mentioned, one of the main benefits of using AI is to reduce engineer workloads through automation. But as we are in the nuclear industry, we know that we have to keep a human in the loop for all decisions, or at least the most important decisions. So the question is, how can we empower engineers to analyze information generated by AI and not being lost within this network of information? And in fact, the virtual twin in the 3D Experience platform already has all the information needed for engineers. We just have to reveal it. And the way we do it is through a dynamic data perspective that allows engineers to navigate on the information and go from an AI results to the connected models of the engineering. And these data perspectives can also be used by the management of the project in order to monitor the progress in terms of engineering and the convergence of the design of a system or a complete plant. Yeah, thank you. So how does it work? So all the results from AI have been integrated in the platform and transformed into objects. So we have a full traceability for each justification from the requirement to the justification generated by the AI and the supporting document. So this is the first thing. The second thing is that we are able to help system architects analyze the results quickly, so understand how many non-compliances they have found, what are the main systems impacted by these non-compliances. And if I am in charge of a given system, like for example the reactor cavity cooling system, I am able to deep dive into the results and see what are exactly the non-compliances identified by the AI. And then I can explore the information which is connected to it. So going from the requirements to the components or requirements to the function, even to the 3D design, and get a good understanding of why it's not compliant. And on top of that, if I'm not satisfied, I can launch an action, so raise an action, either to reinvestigate the design and find a new solution, or just to update the design document in order to take into account the missing information. And here what we are showing is, as I said, we need a human in the loop for the decision. So each justification has its own life cycle, which means that we are capturing the review and the final decision from the engineer, knowing who and when the decision was taken. So now, I think the next step is to go to the compliance report generation. Béranger, do you think that we can also ask AI to do that for us?
Of course. So the compliance report begins with a short functional analysis, which provides some context, technical context about the HTGR. So regarding the use cases, functions, and main systems. And then it displays some KPIs about the compliance and finally the compliance matrix. And all of these compliance elements are automatically generated from 3D experience. So we can create a compliance report template where we can choose the KPIs that we want to display, which are automatically calculated, linked to the data compliance that Xavier showed you. And after that, we can also display the compliance matrix, and we can also add KPI diagrams as well in this report. So these elements are automatically calculated, but the functional analysis is also automatically generated based on the main use cases that model the main functional activities of the HGR and the block definition diagrams that model the main system, subsystem, and their interactions. And we developed a model-to-text script that analyzes and worked on this data to then call an LLM that produce an analytical, textual analytic of these models. So to illustrate that, we are here in a Katia Magic environment, so we can extract an XML file from these models, and we can import them into our user interface. So at first, we have an analytical script that analyzes these hierarchical structures, and then we can call an LLM that produces a textual description of these models, first for the UC diagrams and then for the BDD diagrams. And the result is a functional analysis, which is produced in a Markdown format, so that we can have an overview just below. And this format gives some textual explanation of these models, and we can export them to then build the.
Do you allow me a comment? Because I think this is interesting what we've shown here, because it's really the capability to use AI not only on documents, but also on models. So if you have spent time to go for a model-based approach and have modeled all your nuclear power plants or system of interest, AI can also be applied to these models in order to produce results like documentation or even compliance analysis based on the models. And really, it really opens a new door for AI, which is not only leveraging text information, but also structured and model-based information. Sorry for... yeah.
And so the compliance report gathers everything together. So starting with the textual description of the HGR, automatically write thanks to our model-to-text script, as Xavier explained. And after that, we can so display the compliance status through the main KPIs and finally the compliance matrix of interest. So we've reached the end of the demonstration, and it's no time to share with you some concluding insight. So what we've built together with Dassault Systèmes and Assystem is an integrated environment where 3D experience ensure the digital continuity and the model-based system engineering methodology, and DeepRex bring the power of AI to accelerate the design process, and it opens new perspective when it comes to talk to compliance, because we can now launch the compliance verification at any stage of the project, and not only at the very end of the V-cycle, which are able to have instantly assess the compliance gap. And we can hence see the issue earlier in order to have the final design convergence quicker. So.
Yeah, so few words of conclusion. So what we presented today is really a unified and ready-to-use approach, which combines the know-how and solutions from both Dassault Systèmes and Assystem. What is important to have in mind is that we are illustrating one potential use case, which is the compliance analysis of requirement compared to requirements at the design stage. But in fact, the same kind of methods and tools can be used to address various use cases, like, for example, checking the compliance of the an answer from a provider or supplier of an equipment. Does it fulfills all the requirements I have submitted? Or even verifying a production and quality plan from a supplier. So what we can do is to invite us to either come for the question after, or to meet us at our booth, where we can replay the demonstration, go into the detail and answer your question, and we can have a discussion also on what are the use cases that are meaningful for your project. So don't hesitate, come to our booth, and we will be happy to showcase again the demonstration.
Thanks a lot.